Now that you've had some time to practice with these questions, I want to go through them with you, make sure that you got them correct and or understand your mistakes. Level 1, the easiest of the increasingly difficult questions today. Look at the triangle to the right and order the angles from smallest to largest. They gave us sides, and we remember that the smallest angle is opposite the smallest side. So 7 is the smallest side, and so the angle opposite that, angle A, is the smallest angle. The largest angle is opposite the largest side. So 11 is the largest side, and therefore angle C is the largest angle. And since we're going from largest to smallest, angle C is going to be listed first, angle A last, and then angle B is the medium angle opposite the medium side or middle side. So the order that you should have had is C, B, A. If you went in the opposite order, A, B, C, you went smallest to largest. So make sure to pay attention in the question when asked, and maybe you even put a box around it, as I've suggested throughout this school year, to remind ourselves, hey, did we answer the question largest to smallest? C was the biggest. Okay, we're good. And if you listed 2 letters, you listed sides, not angles. So again, pay attention to the detail of the question. Level 2, a little bit more challenging. This time there's no picture given, and they give us 2 angles, and they want to know which side is the shortest. This is very similar to a drill question today, so hopefully you were able to get this one pretty easily. A, B, C. A, B, C. B is 58 degrees. C is 81 degrees. So we need to find angle A. And the triangle sum theorem from last chapter says that angle A plus 58 plus 81 equals 180 degrees. So we subtract 139 from 180, and angle A equals 41 degrees. Now that we have that, we can determine which side is the shortest, because that side will be opposite the smallest angle. If you said side AC, you would have been correct if they only cared about these 2, the sides opposite those 2 angles. But because they talked about the whole triangle, which side of the whole triangle, so we have to consider all 3 sides. And angle A happened to be the smallest angle, and therefore side BC is the smallest side, and we write that side or line segment BC. Remember, there is no segment marking above the letters if we're talking about its measurement, like an actual number value, but when we're talking about it by name, we write the symbol of line segment above the letters. Going back to chapter 1. Alright, a little bit more challenging now, level 3. The exterior angle to the vertex angle of an isosceles triangle has a measure of 65 degrees. What is the measure of a base angle of the triangle? This one is exactly like drill question number 1. It says the vertex angle exterior 65 degrees. These sides are congruent, so these base angles are the same. And so we know that x plus x equals 65, and they want to know the measure of a base angle. So just one. All right, 2x equals 65 degrees, divide by 2, x equals 32.5 degrees. Again, using the exterior angle of a triangle theorem, telling us that these two inside opposite interior angles from that exterior angle equal the exterior angle when added together. So their sum. Level 4. In triangle ABC, exterior angle to A. Alright, so let's go ahead and draw ABC. A, B, C. Exterior to A is 110. Exterior to B is 132. So if this is 110, inside here is 70. 180 minus 110 is 70. Over here, angle B, 180 minus 132 is 48. And they want to know which side of the triangle is longest. That was a bad box. Which side is longest? Well, I need to find angle C in order to answer that question. So again, using the triangle sum theorem, C plus 70 plus 48 equals 180. 70 plus 48 is 118, which we'll subtract from both sides of the equation to get the measure of angle C equal to 62 degrees. And we want to know which side is the longest. Well, that's opposite the largest angle, which is angle A. So the side longest is side CB. And if you had side BC instead of side CB, you would be correct. The order of the letters in this case do not matter. And finally, level 5, the most challenging of them. In triangle EFG, F is 10x, E is 20x minus 10, G is 11x plus 26. They tell us that it is an isosceles triangle where side EF is congruent to side FG. That tells me that these angles, E and G, are congruent. And if I want to know what the value of x is, the fastest approach is to say 20x minus 10 equals 11x plus 26 using the isosceles triangle base angle theorem. And the 10x is a extraneous piece of information. At this point, we subtract 11x from both sides of the equation, and we will add 10 to both sides of the equation at the same time. So 36 equals 9x. Divide both sides of the equation by 9. X equals 4. There is, however, another way to come up with the answer to this question that strictly uses old information, and that would be the triangle sum theorem. 20x minus 10 plus 11x plus 26 plus 10x, where we add all three angles together and set them equal to 180 degrees. This will be a longer process, and it uses old information. But that would not be wrong. You would still get x equals 4 following that. It will be best for you, though, if you can recognize the isosceles triangle base angle theorem here and work through this question in this way. Now to take a look at the proofs. The first of the UTRI proofs had all of the conclusions written in order for you. All you needed to do is match the justifications and mark the picture. Let's see how you did. The first conclusion is always the given. So hopefully you got that one correct. And it said that these lines are parallel, and that's already marked with those arrows. It also said that angle A was congruent to angle E. That was given. Now, we also know that angle A is congruent to angle CBD, and that angle E is congruent to angle CDB for the same reason. If I extend these parallel lines, you should see that this would be the bottom. Here, I'll even extend the transversal. So here, this bottom left and this bottom left, they're in corresponding positions. That would be the corresponding angles postulate, which we have been abbreviating CAP. Now, angle CBD is congruent to angle CDB. That we already have drawn on the picture, so we know that to now list, and that would be through the transitive property of congruence. Which leaves us with only one thing left, but let's just talk through to explain beyond just, oh, it's the only one left, why this is true. Because I know these angles are congruent, I then know sides of this triangle are congruent, which is what I was asked to prove. Side BC congruent to side DC, and that of course is the converse of the isosceles triangle base angle theorem, which starts with angles and goes back to sides, proving the triangle is isosceles. Number 2. This time the conclusions and justifications were left blank, but there was a bank for you to help out. We always get started with the given exactly as is. AD, side AD is congruent to side AE, and angle D is congruent to angle B. I know this is true because it was given. I put that information on the page. Side AD, or on the picture, is congruent to side AE. Angle D is congruent to angle B. Alright, there's lots of things that we can tell just from the picture and the information that's given there. But our objective is to prove the lines are parallel. So, what will flow next? Well, because these sides are congruent, I have an isosceles triangle, and then angle D is congruent to angle E. I know that, and that helps out a lot. And that was the isosceles triangle base angle theorem. Tells us that. I then can say, because I see in the picture, that angle E is congruent to angle B, and that's important. And the reason for that, transitive property of congruence. Some people had asked last chapter, is transitive property of congruence or equality always going to be last? That was true last chapter for most of the proofs, but that will not be the case all the time moving forward, because in the last chapter we were just introducing proofs, and particularly proofs using the transitive property. Now that's just another tool in our bank or in our toolbox. In this case, it's not the last step, and it will not necessarily be the last step moving forward. The final is the prove statement. We have enough to say that segment DE is parallel to segment BC because angle E and angle B were congruent, and they are alternate interior angles. Since I'm going from angles to prove lines parallel, we use the alternate interior angles theorem. If we knew the lines were parallel, and we then were going to say from that information that the alternate interior angles were congruent, then we would use the parallel lines theorem. Alright, and that finishes up this proof. For proofs 3 and 4, this is a bank to be used in questions 3 and 4. If you did not answer them yet, I would recommend taking a picture of this. If you don't have the page in front of you, if you do have the page in front of you, just keep this to the side while you try 3 and 4. We'll start with proof 3, and again, if you haven't done this one yet, I would recommend pausing the video and trying it at this point using again that bank that is combined for number 3 and 4. Once you believe you have it, unpause the video and see if you did it. The first item is always the given written as is, and that says that line AC is parallel to line DE. It says that angle ABD is congruent to angle CBE, and that was the given information. Next, ABD is congruent to angle D, so these two are congruent, and that would be because of the parallel lines theorem telling me that alternate interior angles are congruent. So you might say alternate interior angles. And that also is why CBE is congruent to angle E. Next, they tell us that D and E are congruent, and whether they wrote it there or not, we could see that was the next logical thing to say, because that's what we were leading towards. And if we're trying to say that this is an isosceles triangle with side BD and side BE congruent, which is what they're asking us to prove, we need to know that angle D and E are congruent. This is the transitive property of congruence. And then finally the proof statement that this is an isosceles triangle because the base angles were congruent. That again is the converse of the base angles theorem. Hopefully you got that one and are on to the last of these proofs, number 4. If you have not done number 4 yet, I would recommend again pausing the video here and giving the proof a try on your own. You can reference the bank that was combined for problem 3 and 4 as a tool to help you out. Once you believe you have it, press play and see how you did. Conclusion 1 is the given written just as it was already. Side AB is congruent to side AC, and angle 1 is congruent to angle 2. Why? It was given. We go to the picture and put that information on there. AB is congruent to AC. That was already drawn for us, but then angle 1 is congruent to angle 2 was not. So we'll add that information. Now, because this is an isosceles triangle, I know that angle 2 and angle 3 are congruent. So angle 2 is congruent to angle 3 because of the isosceles triangle base angle theorem. And this time I went from isosceles triangle to now know that the angles are congruent. That was the base angle theorem, not the converse. The next thing, well, I now have shown that, or I've introduced this other congruent angle, 3, which was congruent to 2, but it's also congruent to 1 because of the transitive property of congruence. And now that I show these angles are congruent, I'm able to say that line BC is parallel to line ED, which is what they asked us to prove. Line BC is parallel to line ED. And that is because of the corresponding angles postulate, which we have been abbreviating CAP. Hopefully at this point, after working through today's lesson, you are more comfortable with the isosceles triangle base angle theorem as well as its converse, the triangle side and angle inequality theorem, and applying those things in the practice problems that you did with the different levels, and also using those in different proof scenarios. At this time, you'll work on the exit pass, and if there is time remaining in class, you can go ahead and start the homework.